Our next reaction is a decomposition reaction. And again, this would be hard to predict the products, but I know this one. I'll tell you what they are: H2O and O2. This is a very common reaction. You may recognize the name of this. H2O2 is hydrogen peroxide. So you may know that if you put hydrogen peroxide on a cut that it bubbles. Well, this is why it bubbles. This is gas that's formed. Of course, this is liquid. This is why it bubbles. This is actually an aqueous solution of hydrogen peroxide. It bubbles because of oxygen. I remember I was always told that it meant that your cut was dirty, but actually you have a catalyst in your body called catalase. We have hydrogen peroxide is formed in our bodies sometimes during the oxidation process of when we're burning food, and so we have an enzyme to decompose it, because hydrogen peroxide is kind of harsh. It will react with your proteins and your cell membranes and damage those. That's how it's used as a disinfectant. It will damage the cell membranes and proteins of the bacteria. In fact, we even have white blood cells that produce hydrogen peroxide and kind of shoot it out at bacteria. But anyway, so this reaction happens in your body. This is a catalyst up here that you will use, manganese dioxide. On this one, I'm just going to balance it. And let's check and see if that's really balanced. Sometimes people make a little table to see if it's balanced with the reactants here and the products there. And then we say we have oxygen and hydrogen. So how many oxygen atoms in the reactants? We have 2 times 2, that's 4. How many oxygen atoms in the product? We have 2 here, because this multiplies through the whole thing, and 2 there. So that's a total of 4 oxygen atoms in the product. For hydrogen in the reactants, we have 2 times 2, that's 4. In the product, 2 times 2, that's 4. So this is balanced. We have the same number before and after the reaction. Our next reaction type is the single replacement reaction. In this type, a more active element can replace a less active one. Let's just look at this top reaction. What element is replacing what element? Zinc is replacing copper. So copper starts off in the compound, and zinc takes its place and displaces it, so the copper's off by itself. So zinc is replacing copper in the first one, and in the second one it's the other way around. Copper is replacing zinc. So only one of those can really occur, because the rule up here says that only a more active element can replace a less active element. Now, activities of elements are hard to predict, and there are tables in your textbook to show you which elements are more active. But let's just say this is an activity table. According to this table, zinc is up higher, so it's more active. Zinc can replace copper, but not the other way around. So if that's true, then the first reaction should occur. So I'm going to get rid of this question mark. And the second one will not occur. So if a reaction doesn't occur, we don't want to write products. We want to write no reaction. In fact, it's wrong to have products written if the reaction does not occur.